Okay, so hello everyone. We're here on our continuation for lesson 13, design of experiment for several factors or several variables. So last time we discussed the fractional replication of a 2K design where we divide the experimental design into fraction, yung 1/2 fraction. And now we will try to do another fractional replication by doing a projection of a 2K minus 1 design. So for a 2K minus 1 design, if we utilize yung mga effect for these cases, yung A, B, and C only, ito yung 2 raised to 3 natin, tama? But we will do a 2 raised to 3 minus 1, so 2 to 2 design with several effects. So for the projection here, and here sa baba, you can see that just doing this 4 runs or experimental runs can have the 4 the 2 level for each factor. For example, for C, you have 2 levels already. For C, for B naman, you have 2 levels, low and high. For A, you have the low A, ito yon, yung low A, and yung high A. For B, burahin ko na lahat yung B naman, you have the low B, low, and ito yung high B. Same then for this case. So meaning we can do a fractional replication where we only need to do this experiment to have observe the interaction for two variables. Okay, now for this example, yung example natin 14-8, we need to have the A and B graph. So, dalawang level lang. So, 3 minus 1 siya. So, kukunin mo lang yung dalawang low ng AB. So, disregard yung BC. So, puntahan natin yung design. So, ito yon. Ito yung D natin. You disregard this one. And you see this negative is double siya. So, para kang may replication. So, this 2 value will be assigned to the negative value for A tsaka D yung power. Ito naman yung parehong high. So, these are positive. So, nakita nyo siya dun sa experimental design. So, parehong positive ito at tsaka itong nasa baba. So, meaning this 749 tsaka 729 will be assigned to this one. So, meaning may replication ka na. Tama? For your A and D power. So, meaning, by doing projection replication or fractional replication by projection, you can reduce the number of experiment and assess the behavior between two factors. Okay? At 2 levels for 2 factors. So, now, ano yung design resolution? So, design resolution, we have this 3, resolution 3, 4, and 5. For resolution 3, these are designed in which no main effect are alias with other main effect. But main effect are alias with 2-factor interaction and some factor interaction may be alias with others. So, in the 2 raised to 3 minus 1 design, we have 1 equals ABC is a resolution for a 3 design. So, we usually employ Roman numeral subscription. So, meaning for this one, 2, 3, 1 design. So, kung ini-employ natin na yung fourth variable natin, which is yung I natin, is the combination of A, B, and C. For resolution 4 naman, these are designed with no main effect, alias with other main effect, or 2-factor interaction. So, wala kang 2-factor interaction. But 2-factor interaction are alias with each other. So, 2 raised to 4 minus 1 design with yung ABCD natin, na yung example 14-8, yung ginawa natin kanina, has a resolution of E4 design. So, meaning yung 2 raised to 4 minus 1 design. So, Roman numeral din siya. Okay, now, for resolution 5 design, these are designed with no main effect or two-factor interaction is alias with any other main effect or two-factor interaction. The two-factor interaction al alias with three-factor interaction. So, basically, ito yung 2, 5, A, B, C, D. Ito yung 5 design resolution natin. So, let's have this 2k minus p fractional factorial. So, this one is for the 4, where we designate I as A, B, C, D, B, C, D, F, and A, D, E, F. So, 6 factor siya. Ito yung mga factor designation natin. So, for A, we can designate it as this one. So, B, C, E, D, E, F, or A, B, C, D, E, F, and so on and so forth. Okay, so let's have an example para makita nyo. Parts manufactured in an injection molding process are showing excessive shrinkage, which is causing a problem in the assembly line. So, kung meron kang material na may mga product na may mga plastic attachment, so yung shrinkage yung usual na problem niya. Diba? Yung mga design ngayon ng packaging, pare-pareho yung bote, magkakaiba lang yung shrinking ay yung plastic label. Okay, so an effort to reduce the shrinkage, a quality improvement team decided to design an experiment to study the injection molding process. So, may 6 factor tayo. We have named them following. Okay. Yan yung 6 factor. Temperature, screw speed, holding time, cycle time, gate size, and holding pressure. May 2 level each. And we want to observe yung factor na to. So, kung gagamitin natin yung 2 raised to 6, ilan to? 2 raised to 6. Kung full factorial, 2 raised to 6. So, we have 64 experiment. So, masyadong madami to for a manufacturing procedure. So, ang ginawa nila, the team decided to use a 16-run 2-level factorial design for this 6 factor. So, the design is constructed writing down at 2 raised to 4. So, 16 runs. So, naka-factorial ka. Fractional pala. Naka-fractional factorial. As the basis design in the factor, so yung 4, yung 4 lang na level, and then setting E and F as ABC and BCD as discussed previously from the previous experiment. So, paano siya ginagawa? So, instead na yung factor ng E at saka F, i-replicate pa natin, parang mag-multiply ka pa ng another 2, ang gagawin na lang natin, you just combine this from the 2 raised to 4 na factorial design. So, paano siya ginawa? So, yung first, you need to rewrite your ABCD. So, kung 2 raised to 4, that's 16. Tama? 2 raised to 4, 16 siya. So, from there, we'll just assign yung E at saka F from the combination of ABC tsaka BCD. So, multiply mo lang to. Ito na yung E. So, kukunin mo yung low value ng E. And yung BCD, yung F BCD, ito. Kukunin mo yung low value ng F. And so on and so on. So, instead of a 64 experimental run, we reduce our experimental run into 16. Kasi naka-fractional siya. Then, ito na yung observed synchrages times 10. Times 10 siya. Percentage to. Okay. Type. So, a normal probability plot of the effect estimate from this experiment is shown in 14.37. So, ito yung figure 14-37. So, as you can see, majority of the plot follow this line, but this 3, yung A, B, at saka AB na experiment, saan siya? AB, positive. Pag sinabi yung AB, positive yung A, ito yon, positive yung A. Ito yung A natin. B, positive lang yung B. B lang yung positive. Ito siya. I think this one. Yan. And yung positive yung AB. Positive ang AB. Positive AB. Positive AB. Dapat negative ang CD. Ito. Ito yan. Ito yung B. Ito yung AB. Okay, ang titingnan nyo lang yung ABCD. Okay, so, meaning this 3 has a significant effect. Ano yung AB, yung temperature, at saka screw speed. Yung AB. So, the only large effect are AB, mold temperature, B, screw speed, and the AB interaction. In light of the alias relationship in table 1420, it seems reasonable to tentatively adopt this conclusion. So, meaning, ito lang yung may effect based from this table, yung 14-28, yung aliases. Okay, the plot of AB interaction in figure 14-38, so ito yon. So, we plot the interaction of A and ito yung B. So, meron kang low B, high B. So, ano yung na-observe natin? So, for low B, which is screw speed, low screw speed, as you can see here, walang masyadong impact ang temperature. But at high rate, malaki yung impact ng temperature. Okay. For this one, ganun din. Yung low temperature, as you increase the speed, medyo may impact na. Okay? So, may significant impact or effect yung change ng speed. Mas lalo na sa high temperature. As you increase the speed, nag-i-increase din yung shrinkage value. So, yun lang yung sinasabi natin. Okay? That process and sensitivity to temperature of screw speed at low setting, but sensitive to temperature of screw speed at high. With the screw speed at low level, the process should produce an average shrinkage of around 10% regardless of the temperature level. So, meaning dito, we can run at any temperature. Pero, low speed lang para mas ma-minimize yung shrinkage. Okay? So, hindi, porket mas mabilis, mas maganda yung production. So, ayun yung isa sa mga tinitingnan. Based on this initial analysis, the team decided to set both the mold temperature and the screw speed at low level. This set of conditions should reduce the mean shrinkage of parts to around 10%. However, the variability in shrinkage from part to part is still a potential problem. So, dito nakita lang natin na ang may impact will be at low setting pareho. Low setting ng temperature at saka pero posible na at this low temperature may effect pa din yung ibang parameter. So kaya kailangan mo pa ng another experiment. Okay? Nasusundan. Okay. So from this plot, we will try to construct yung equation, and from this equation we will try to calculate the predicted value and calculate the residual. So from that we will plot a residual plot, and ito yung residual plot. So plotting the residual with normal probability, as you can see linear siya, so meaning this shows a good the plot of the residual versus each factor were then constructed. One of this plot done for the residual factor C holding time is shown in figure 1440. So, yung 1449, satisfactory siya. So, titingnan nyo kasi linear. Pero pag tiningnan nyo na siya per factor, so for this one, holding factor, makikita nyo na at low holding time, mababa yung variability. But at high holding time, mataas yung variability. So this could have an effect in your model. So this residual obtained the usual way from model predicted shrinkage. So the regression model used to produce the residual essentially removes the location effect of AB and AB from the data. So the residual therefore contain information about unexplained variability. So figure 1440 indicates that there's a pattern in the variability and that the variability in shrinkage for parts may be smaller when holding time is at low level. Okay, so meaning this one could also affect the performance of the machine or yung production. So practical interpretation, figure 14.-41 shows the data from this experiment projected on a cube in the factor A, B, and C. Kasi nakita natin yung A, B, and C has an impact. So average observed shrinkage and range of are shown at each corner of the cube. So ito yung ating variable, mold temperature, holding time, at saka screw speed. Nakita natin na may impact yung tatlong to. And if you assess yung shrinkage behavior, so yung lahat ay low, yun yung pinakamababa, yung shrinkage. As you go from point to point, makikita nyo na nagbabago yung shrinkage. Lalo na dito, pag naka-high yung setting ng lahat. Okay? So yung R value, may R value ka dyan na kinukompute. Usually, that's just the error. Okay? Error ng assessment. Okay? So, I think we'll end here for this lesson. Okay? So, next video, we will we'll discuss response surface method and